All right, today we are going to talk about the leading coefficient test for polynomials. So the leading coefficient test talks about end behavior, but first let's talk about some vocab. So in order to know how the leading coefficient test works, we need to know what a leading coefficient is and what a degree is. Now these are two vocab words that we have definitely talked about before. Where do you find these two vocab words within a polynomial? You find them in the term that has the greatest exponent. So if you look at this entire polynomial, the biggest exponent is 4, and that is the degree. So the degree is 4, and the leading coefficient is 1, because that is the coefficient that is attached to that term with the largest exponent. So let's look at another example. 7x squared plus 6x to the 8th minus 5x plus 8. Now we look for the leading coefficient and degree in the term that has the largest exponent. So 7x squared does not actually contain the leading coefficient and degree. You look for 6x to the 8th, and that's where your information is found. If this was in standard form, 6x to the 8th would be first. So the leading coefficient here should be 6 and the degree 8. These are really important to be able to pull out of a polynomial in order to find end behavior. So within your Desmos activity, you should have discovered different things about the leading coefficient and degree. So here I'm going to make a little table. We have positive leading coefficient versus negative leading coefficient, and even degree versus odd degree. The first one we're going to talk about is a positive leading coefficient with an odd degree. An odd degree means that your end behaviors are going to be going in opposite directions. So it doesn't matter what's going on in the middle, remember, it's just what's going on either end. So I like to think of this kind of like a linear positive slope. You have negative infinity on the left side and positive infinity on the right side. So positive leading coefficient with an odd degree gives you, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches infinity, f of x approaches positive infinity. Now this is exactly opposite for an odd degree and negative leading coefficient. So now we have more of like a negative slope. Anything can happen in the middle, but on the left side, as x approaches negative infinity, we're going f of x goes to infinity. On the right side, as x approaches infinity, f of x approaches negative infinity. So notice anytime there's an odd degree, that's the largest exponent is odd, we have our end behaviors going in opposite directions. Which directions those go in, those depend on the leading coefficient being positive or negative. Now, when we have an even degree, that means that those end behaviors are going in the same direction. When they're positive, when the leading coefficient is positive, both of those end behaviors are going to infinity. So you have, as x approaches negative infinity, f of x approaches infinity. And as x approaches positive infinity, f of x approaches infinity as well. So notice, even degree, they're both going the same way. Odd degree, they're going opposite ways. The leading coefficient tells you which way they're going. So the last one, if I have a negative leading coefficient and an even degree, they're both going down. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches negative infinity. So this is a great visual to have in your notes. I write this all over everything when I'm working with polynomials. And really, I focus on if it's odd, opposite directions, even, same direction. If it's positive, you have something like a positive slope or both are going up. If it's negative, it looks sort of like a negative slope and they're both going down. These are just helpful ways to remember the leading coefficient test. So now we're going to go through some examples. I'm going to end up sorting these. So negative 2x to the 4th plus 3x squared minus 5x. Now my degree is even. My degree is going to be 4 because I have negative 2x to the 4th. Since I have an even degree, I know they're both going to go in the same direction. My leading coefficient of that is -2. So that means they're going in the same direction and they're both going down. So I'm going to sort that into, as x approaches -infinity, f of x approaches -infinity. As x approaches infinity, f of x also approaches -infinity. Next one. 3x squared minus 4x to the fifth plus 5x minus 2. It's important to recognize in this one that it's not in standard form. X squared is not where your degree is found. -4x to the fifth is where your information lies. So this has an odd exponent, which means your end behaviors are going in two different directions. It has a negative leading coefficient of -4. So that means I'm sorting this one top right. And I've got, as x approaches -infinity, f of x approaches infinity. As x approaches infinity, f of x approaches -infinity. And that's all coming from the -4x to the fifth. So our next one is x cubed minus x squared plus 3. So x cubed is where my information is. I can't see it, but my leading coefficient is 1. My degree is going to be 3. So in this one, because my degree is odd, I know that my two end behaviors are going in different directions. My leading coefficient is positive, so that means I'm sorting it top left. As x approaches -infinity, f of x approaches -infinity. As x approaches infinity, f of x approaches positive infinity. And my last example here is 4x squared minus 3x. 4x squared is where my information is. 4 is positive, 2 is even. So that means both ends are going up. So I have, as x approaches -infinity, f of x approaches infinity. As x approaches infinity, f of x approaches infinity. So notice in this visual, you can see in the bolded term, that's where your information is coming from.